Hi friends, in this video we will understand Michelson Morley experiment. In my previous video related to ether, I had told you that it was the most famous experiment in which scientists tried to prove the existence of ether. In this experiment, Michelson and Morley tried to prove the motion of Earth through ether. It means the ether is stationary and Earth is moving through it. Because in ether hypothesis, it was assumed that ether is stationary and all heavenly bodies are moving through it. This experiment was using an interferometer, that is a device capable to detect even a slight shift in the interference fringes formed due to the superposition of two coherent beams. For that, they used the interferometer called Michelson's interferometer. This Michelson's interferometer was placed over a stone that was kept floating over the mercury so that it may be rotated about a vertical axis in any desired direction. In this interferometer, a source of monochromatic light was used to produce a collimated beam of light. The beam was collimated after passing through a slit in a screen, and then this collimated beam of monochromatic light was made incident on a partially silvered mirror. This partially silvered mirror partly reflects the light and partly transmits the light. This mirror was placed at an angle of 45 degrees with the horizontal so that it may reflect and refract the beams of light in mutually perpendicular directions. And these two beams of light, one reflected by M, another refracted through M, will form two coherent beams of light. These two beams later on, after reflections from M1 and M2, will come back to M, and after reflection and refraction through M, they will superpose in the field of view of a microscope, forming the interference fringes. Michelson and Morley will rotate this apparatus through 90 degrees so that the fringes may shift in the field of view due to change in path lengths covered by light along two directions. These two mirrors M1 and M2 are placed at the same distance D from M but in mutually perpendicular directions. Since Earth is continuously moving around the Sun with orbital speed 3 into 10 to the power 4 meter per second, so the entire apparatus, means the interferometer, will also be moving along the Earth with the speed 3 into 10 to the power 4 meter per second. So mirror M1 is along the direction of motion of Earth, while mirror M2 is perpendicular to the direction of motion of Earth. Now, if we consider the light reflected from M and reaching at mirror M2, then this light will have two components of velocity, one along horizontal direction having speed v and another along vertical direction having speed c, speed of light, and the resultant of these two can be obtained by parallelogram law of vectors So the light will go along this path to reach at mirror M2 at position M2 dash. At this instant, this mirror M will also come to its new position M dash. If time taken by light in reaching from M to mirror M2 is T, then in this time horizontal distance covered by mirror M2 or mirror M will be Vt. It means this horizontal distance will be Vt, V orbital speed of Earth, and T the time taken by light in reaching from M to M2. Also the speed of light after reflection from mirror M will be under root of C square plus V square. As V square will be negligible as compared to C square, this speed will be approximately equal to C. So light will move with speed C from mirror M to M2 in the direction M to M2 dash, and hence this distance M2 dash will be C into T. So this time taken by light from mirror M to mirror M2, that is T, can be determined using triangle M2 and M2 dash, and from this triangle by Pythagoras theorem C square T square minus V square T square will be D square, that is D square is equal to C square T square minus V square T square. This implies T square is equal to D square upon C square minus V square. This can be written as D square upon C square taken as common 1 minus V square by C square. This implies T is equal to D upon C root 1 minus V square by C square. This is equal to D upon C into 1 minus V square by C square raised to the power minus half. This is equal to D upon C into, as V square upon C square will be less than 1, by binomial theorem 1 plus x to the power n will be 1 plus nx when x is less than 1. So this n will get multiplied here and we will get 1 plus V square by 2C square. It is the time taken by light in reaching from mirror M to M2 dash. Now we will determine the time taken by light in reaching from M to M2 dash and then back to M. And we know that after reflection the light will follow the identical path same as M2 dash to reach back to M at the position M double dash. After reaching at M dash, it will be refracted through it to enter in the objective of a microscope. Now the time taken by light from M2 dash to M double dash will be same as the time taken by light from M to M2 dash, because both the paths are identical. Hence, time taken by light from M to M2 dash and then back to M at the position M double dash, because in the time in which light will be returning back, mirror M will reach at the position M double dash. This time say is T2, 2 because it is the time for mirror M2. T2 will be equal to 2T, twice of this time, and twice of this time means 2D upon C into 1 plus V square by 2C square. Now we will determine the time taken by light in reaching from mirror M to M1 and then back to M. If this time is T1, then T1 will be equal to first time from M to M1. Light is moving in the direction of motion of Earth to catch the mirror M1, and hence if we will consider that these two speeds, that is the speed of light as well as speed of Earth, are relative to ether, then the relative speed of light with respect to Earth, that is with respect to mirror M1, when light is moving towards mirror M1, will be C minus V, because when both the objects are moving in same direction, then the relative speed is equal to the difference in two speeds. So this time, to make mirror stationary, we will have to determine speed of light with respect to mirror M1, and that will be C minus V. Distance between these two mirrors is D. It means to strike mirror M1, light will have to cover a distance D with speed C minus V. Hence, time taken by light refracted from M and striking the M1 will be D upon C minus V. In this time, D upon C minus V, the mirror M1 will travel a distance equal to D upon C minus V multiplied by V. Time multiplied by speed, and speed of Earth is V. Speed of Earth means speed of mirror M1. So light refracted from M will strike the mirror M1 at a distance equal to D upon C minus V into V, that is at this position. Say after reflection from M at the position M1 dash, the light will be bounced back, and this bounce back light now will approach mirror M, and this light will approach mirror M with speed C plus V, because this time mirror M will be moving with Earth towards the light, and light will be approaching the mirror. So the relative speed of light with respect to mirror will be C plus V, and distance between two mirrors will still be D. So time taken by light in reaching back from M1 to M will be D upon C plus V, and in this time D upon C plus V, again the M and M1 dash will move a distance D upon C plus V into V ahead of their new positions. So it means when light will strike back at M, then m1 dash will be somewhere here at m1 double dash. This light coming from m1 after reflection will also reach m to get reflected and enter into the microscope attached to the interferometer. In field of view of this microscope, the light incident from M2 and light incident from M1 will interfere to form interference fringes. Now T1 is equal to d upon c minus v plus d upon c plus v is equal to d common, and LCM will be c square minus v square, and here c plus v plus c minus v, it will become 2c into d upon c square is taken as common to get 1 minus v square by c square. This implies T1 is equal to c will get cancelled, 2d by c into 1 minus v square by c square raised to the power minus 1, and this is equal to 2d by c, and again by binomial theorem minus 1 will come here, so it will get 1 plus v square by c square. From 1 and 2 we find that even though light travels same path d plus d, 2d here and 2d here, yet the time taken to cover these two paths are not same. In this direction light covers the path with speed c only, while in this direction due to relative motion between ether and light and also ether and earth, because we had taken the speed of light as well as of earth with respect to ether only, so due to the relativity in motion of light with respect to earth, time t1 is found to be different from time t2. Now this time difference can be used to determine the path difference between the two interfering coherent beams produced by mirror M. Difference in times taken by light from mirror M to mirror M2 and back to M, and from mirror M to M1 and then back to M. That is the difference of T1 and T2. We find that T2 is less than T1 will be delta T is equal to T1 minus T2. This is equal to 2d by c 1 plus v square by c square minus 1 minus v square by 2c square, and this will become 2d by c into v square by 2c square, that is v square d upon c cube. Now we will determine the path difference corresponding to this time difference. As time along the direction of motion of earth, that is T1 is more, so path length along the direction of motion of earth means from M to M1 and then back should be more. Hence the path difference corresponding to this time difference can be determined by multiplying time with speed, because speed into time difference will be path difference. So path difference, say delta x dash is equal to c into delta t, that is c into v square d upon c cube. It will give v square d upon c square. Now the entire apparatus is rotated through an angle of 90 degree, so that this longer path becomes shorter while this shorter path becomes longer. So due to the rotation of apparatus through 90 degree, a negative path difference of same amount will also get introduced in the paths of two interfering beams. Hence, the total path difference on rotating the apparatus by 90 degree, delta x will become delta x dash minus delta x dash, that is twice of delta x dash, is equal to 2v square d upon c square. If wavelength of light is taken as lambda, then for path length lambda there will be a shift in one fringe, because one wavelength will correspond to a shift in one complete fringe. So path difference lambda will correspond to a shift of one fringe, and hence path difference 1 will correspond to a shift of 1 by lambda fringes. Now we want to find out how many fringes will get shifted due to the path difference delta x. Due to path difference delta x, number of fringes shifted will be delta x by lambda. Hence, the number of fringes shifted due to this path difference n will be delta x divided by lambda, that is 2v square d upon c square lambda. It means if we consider that ether is stationary, earth and light are moving with respect to ether, then according to theory the number of fringes shifted in the interference pattern seen within the interferometer should be given by this expression. Now we will determine the number of fringes shifted in their experiment by multiple reflections. Michelson and Morley increased the distance d between the mirrors m and m2 and m and m1 up to 11 meter. So d was increased to 11 meter by multiple reflections, and v and c already we know, while wavelength of light used was 5500 angstrom, that is 55 into 10 to the power minus 8 meter. Using these values we get n is equal to 2 v square means 9 into 10 to the power 8, d means 11 upon c square 9 into 10 to the power 16 into lambda 55 into 10 to the power minus 8. This is equal to minus 8 will become 8 here, so 16, 10 to the power 16 will get cancelled, 9 will also get cancelled, 11 5 ja 55, so will be 2 by 5, that is 0.4. It means 0.4 fringe should shift in the field of view of the microscope attached to the interferometer. Michelson and Morley repeated this experiment at several times and at several places, but they could not detect any fringe shift. Since there was no fringe shift observed in the interferometer, the theoretical calculations does not agree with the experimental observations. As theoretical result does not agree with experimental observation, the existence of a medium like ether could not be proved by Michelson Morley experiment. It means there was no medium like ether. That is, the relative motion through ether is meaningless. Through this experiment, Michelson and Morley could not establish the relative motion between earth and ether. It means they could not prove that there is relative motion between earth and ether. Even though the result of Michelson-Morley experiment was negative, but this negative result was explained by scientists in their own way. The first explanation for the negative result was the ether drag hypothesis. It means the scientists assumed that the earth is carrying the ether with it. It means ether is not stationary, that is moving with earth. That is why there is no relative motion between earth and ether. Second thing, the scientists suggested that the speed of light is constant. That is, the speed of light does not depend upon the relative motion. That's why the time taken along the two paths will be same, and hence there will be no fringe shift because of no path difference. The third thing, the Lorentz and Fitzgerald length contraction. Lorentz and Fitzgerald told that the length of path covered by light along the direction of motion of earth shortens by a factor under root 1 minus v square by c square. It means this distance d shortens by a factor under root 1 minus v square by c square. So new path length between m and m1 should be d dash equal to d root 1 minus v square by c square. And this shortening of path difference was responsible for no time difference or no path difference between the two interfering light beams, resulting in no shift in interference fringes within the microscope. Using this expression, we can show that time t1 will be equal to t2. If we will put d dash instead of d in t1, we will get t1 is equal to 2d by c. 2 d means d dash upon c and 1 minus v square by c square. This is equal to 2 d dash is d root 1 minus v square by c square and divided by c into 1 minus v square by c square. This is equal to 2d by c and root 1 minus v square by c square equal to 2d by c into 1 minus v square by c square raised to the power minus half equal to minus half will come here. It will give 2d by c 1 plus v square by 2c square, and this is equal to t2. It means due to the contraction in path along the direction of motion of earth, the time difference and hence path difference will be 0, and if path difference will be 0, fringe shift will be 0. Hence there will be no fringe shift observed in the field of view of the microscope.